I'm going to be talking about a synthesis of some of the work that our group has been doing at Cold Lake, looking specifically at potential sources of contaminants near in-situ facilities. So again, we're interested in sources of contamination around the in-situ drilling pads. So the opportunity to work at Cold Lake is an important one because there are no refineries or upgraders nearby. So this means that we can look specifically at the in-situ industry without the confounding sources of contaminants around emissions from the upgraders. So in 2013, our research group published 2 separate papers that looked at spatial and temporal trends in contaminants at Cold Lake. One paper focused on metals and another one focused on PAHs. And those initial studies were specifically designed to look at potential atmospheric contaminants around the in-situ plants. So we concluded there was no evidence of metal contamination, but that perhaps there were potentially some localized sources of PAHs around some of these sites, but it didn't appear to be consistent with an atmospheric source. So I'm just going to take you briefly through those initial studies. Again, so we looked at a spatial and a temporal assessment, and I'm going to focus mainly on the PAHs because that's where most of the story is. There didn't seem to be much of a metals story. So we looked at spatial trends in PAHs in 2 different environmental media, so mainly in soils, and then also in spruce needles as well. But we didn't have as great spatial representation of the spruce needles as we would have liked. But again, mainly focusing on the soils, and again, looking for an atmospheric source. So again, we were expecting to see that sites that are close to those drilling pads or downwind of them would show higher concentrations of PAHs. So in essence, we were expecting that these sites here would show higher concentrations than these sites. But that's not what we saw. Well, we found that for the most part, PAH concentrations in our soil samples were very low. So the black bars are the unsubstituted PAHs, the parent PAHs, and the hatched bars are the alkyl PAHs. And for the most part, again, they're very low. We didn't see that trend where soil samples located close to the drilling wells were higher and those located not downwind were lower. We didn't see that. We did see that PAH concentrations were elevated in 2 different soil samples, and I've highlighted them here. One of them, this S3, is located right in the middle of the most concentrated area of development. So concentrations in that sample were high, but in the 2 neighboring samples, in S21 and S5, concentrations were very, very low. And again, this to us was not consistent with an atmospheric source. And then the second site to show elevated PAH concentrations was S22, which was located outside of that concentrated area of drilling pads, just to the south near Hilda Lake. And so we didn't only want to know just what the total concentration of PAHs were, we were also interested in which compounds in particular would be enriched in these soil samples. You know, PAHs include dozens of different compounds. They all behave very differently in the environment. They all come from different sources. So we wanted to know specifically, these sites are elevated, which compounds in particular should we be looking at? So very simply, we looked at the individual compounds in S22 and in S3, and we compared them to the average across all of the remaining sites. Now, I don't expect you to be able to read all the names on the bottom, but basically as you move from the left to the right, you're increasing your molecular weight. So the 2-ring PAHs are on this side here, and then as you move to the right, you're moving towards the higher molecular weight PAHs. So the S22 and S3, they're enriched in higher molecular weight PAHs, and S3 in particular is really enriched in C2 phenanthrene. So again, we also looked at PAHs in spruce needles, and by and large, the concentrations of PAHs in our spruce needles were very low, with the exception of one sample, and that was the sample that was actually furthest away from the development. So I'm actually just going to go back a few slides to that map and point it out. So it's P16, and you can see that it's at the very bottom of that map. So it's actually located fairly far away from the in-situ development, but it's located close to the Canadian Air Force's base at Cold Lake. And so we think that this enrichment in PAHs in P16 is really just related to the airport and operations there. In general, looking at the composition of PAHs in our spruce needles, the dominant compound is acinaphthalene, a lighter molecular weight PAH. So again, the spruce needles and the soils give us a sense of what current contaminant trends are at Cold Lake, but what we're really interested in is how they've changed over time. Again, what's the baseline concentration and have they increased since development began? And so to get this temporal assessment, again, we collected lake sediment cores initially from 2 lakes located just south of the major development, a Hilda Lake and Ethel Lake. And if you'll recall, Hilda Lake was where the one soil sample that we looked at that was elevated was taken from. So we looked at metals and we looked at PAHs. So the metals, again, this is post-1900, as Colin pointed out. This is right around the time that you start having increased long-range transport of pollutants, and we see increases in lead and mercury at around this time, consistent with what you see in sites across Alberta and elsewhere. But no further increases after 1985 when commercial in-situ bitumen extraction began. So similar to the soil samples, we didn't see anything that we would say is evidence that the in-situ industry is increasing metal burdens in these lakes. Now the PAH trends were a little bit different. So this is the profile for Ethel Lake. So the black circles, those are the parent PAHs, the unsubstituted compounds, and the white circles are the alkyl PAHs. So this red line here is showing the timing of oil sands development. So everything under that line would be considered pre-development or baseline conditions. And right off the bat, you can see that baseline conditions are very variable. And we really don't have a strong increase in concentrations after development began. There's maybe an increase above baseline in the 2 surface most samples for the alkyl PAHs. But again, we have a lot of natural variability to contend with in terms of interpreting this. So Hilda Lake is a little different. So Hilda Lake, we don't have the same kind of back and forth in the baseline. It's actually a very, very steady baseline. And this makes it a lot easier to see how conditions have changed after 1985. So we see that we have, alkyl PAHs are largely absent. They're very, very low concentrations in the pre-development sediments. And then they increase noticeably. So you can see, they sort of increase as sort of this pulse motion. So they increase after 1985, decrease again, increase, and go back down. So it's almost like a pulse signal. And we see the same thing in the parent compounds. So again, we do see a signal of enrichment after 1985 that makes us think that this might be related to the in-situ industry. But we're not just interested in total concentrations, we're also interested in specifically which compounds are increasing. So we wanted to look at the composition and see which compounds are driving that increase. And actually the increase in PAHs in Hilda Lake are largely driven by just a few compounds. So for the parent compounds, it's almost entirely driven by acinaphthalene. And for the alkyl, it's just 2 really. It's C1 fluorine and C2 phenanthrene. So very few compounds driving this increase. And then for Ethel Lake, those 2 surface most alkyl PAH samples are mainly alkyl naphthalines and alkyl phenanthrenes. So, we had these 2 lakes that were side by side showing very, very different trends. We saw the same thing in our soil samples where one would be high and the neighboring ones would be low. We weren't seeing anything that we thought was consistent with an atmospheric source. So at the time, we concluded that maybe there were some localized sources of of PAH contaminants in particular, but no widespread trend. And right around the time that we published that PAH paper, the story broke in the news about the bitumen seepage events that were occurring at the Primrose Lake site at Cold Lake, so uncontrolled bitumen emulsions to the surface. And so again, we had just concluded that localized PAH contamination might be important at Cold Lake, and then we had this very dramatic example of localized contamination occurring. So we went back to our initial sampling design, and we wanted to see, did we capture that site at all? And what we realized is that we completely missed that Primrose Lake site in our initial study. We were very much focused on the southern end of the development. That's the most concentrated area of development. And we entirely missed the Primrose site in our sampling design. And so this is when we partnered with Colin Cook to return to Cold Lake and to try to capture this important area that we missed in our original sampling. And so we added a third lake to our historical reconstructions, a lake about 2 kilometers away from one of the bitumen seepage sites, site 921. So basically, we wanted to reconstruct that baseline for an area where, as close to that problem area as we could get. So we're about 2 kilometers away. So the site of the bitumen leak was just at this unnamed water body that I've circled here. So that water body was subsequently drained and the sediments were excavated. So we're as close to that as we could get, about 2 kilometers away. And we thought that there might be, a groundwater aquifer that connected the two sites. But mainly, again, we wanted to look at this historical record. We want to see how have concentrations changed since development began, and can we use that background to understand, the overall contamination trends in this area that is having this problem. So we looked at metals and we looked at PAHs. So this is the results for the metals. I've shown them in 2 different ways. So the top plots are just looking at the total concentration, and the bottom one is looking at flux. So we're correcting for sedimentation rate. So the red line again, this is when commercial bitumen extraction began on site. So, if we look at mercury, for example, again, we see that post-industrial increase, but nothing after 1985, nothing in vanadium, maybe an increase in nickel and zinc, a slight increase, an increase in tin, but that begins earlier, begins, 1950s, before oil sands operations began. So some slight increases in metals. Look at the flux rates. Again, we see the increase in nickel and zinc. Maybe we see it in vanadium now and mercury. But again, we also have nothing outside of the range of natural variability. So we've had larger peaks earlier. So maybe a metal trend, certainly more so than Hilda and Ethel. But again, not a really dramatic metal story here. But if we look at the PAH trends, and again, we have the unsubstituted or parent PAHs separated from the alkyl. The red line, timing of oil sands development, 1985. No increase in our unsubstituted PAHs. If anything, they're continuing a declining trend from a subsurface peak. But we do see a clear increase in our alkyl PAH compounds in both the flux and the total concentration. And unlike Hilda, which was sort of a pulse increase, this is a sustained, steady increase. And again, we're not just interested in concentrations. We want to know specifically which compounds are driving this increase. So the top plot is comparing the specific PAH compounds between the post-1985 sediments and the pre-1985 sediments. So we see very clearly there's a strong increase in C2 naphthalene. That's the biggest difference that we saw. We also saw increases in our alkyl fluorines, our alkyl phenanthrines, and our alkyl dibenzothiophene. And then we wanted to compare that to the composition of PAHs in bitumen. Again, this is the area where we had that large bitumen seep occurring. So we were actually able to get a sample of the bitumen, so what had actually seeped out of the ground. And we analyzed the PAHs in that to compare to our sediment trends. So all of these compounds that we saw increasing are present in that bitumen sample, but obviously the proportions are much different. And some of the important compounds in that bitumen emulsion were not increasing in our sediment core. So they've become more similar, but not the same. And then this plot here is just another way of showing that exact same thing. So what I've done here is I've done a principal components analysis on the composition of PAHs in the sediments. So essentially taking all of that data, all of those dozens of compounds, and sort of condensing them down to two values, this PCA axis 1 and PCA axis 2 scores. And this is just, again, a way to visualize changes in the composition of PAHs through time, and particularly the composition after development begins. So we did have, again, we see the same thing, a clear change in the composition of PAHs after development, so a shift along the x-axis. And you can see the surface, the most recent interval highlighted there. And we also plotted passively the composition of bitumen in that bitumen seep that we recovered, as well as an older sample of archived cold lake bitumen that we've received from our colleague Bruce Hollowbone at Environment Canada. And we can see that the composition of PAHs in the surface sediments of Lake 1226 have become more similar to the composition in the bitumen seep. And again, I should clarify, not the same, but more similar. And so we do think we have a clear petrogenic source here, but we're not entirely sure yet what that source is. It's more similar to the bitumen, but it's not the same. So just in summary, we have evidence of increases in PAHs certainly in two lakes that we've looked at after 1985, and potentially in the third lake, at the lake as well. But the trend is very different between those two lakes, and the exact composition of the PAHs that are changing are also very different. And again, this is true for two lakes that are essentially side by side. Hilda and Ethel Lake are neighboring lakes, and they show very different things. So I think the first lesson to learn from this is we've heard a lot today about the importance of baseline data, and again, if we're looking at baseline data in the Cold Lake region, all of this variability that we're seeing in just these three cores that we've looked at is really saying that we can't take just 3 lakes to be representative of the region. We need a more robust lake set in order to really understand what the regional variability is and how that's changing since development began. We don't really see much by way of the metals. This really does seem to be a hydrocarbon story. Maybe some trends we're looking at in 1226, but again, the strongest trends are in the PAHs. And the last point here, we still don't really know what the sources are and what the potential mechanisms are for these increases that we're seeing in our lake sediments. And this is an important point because we need to remember that lake sediments are not just archiving what's going on in the lake. They're also archiving what's going on in the surrounding catchment as well. So they're connected to the terrestrial landscape through hydrological pathways, through surface water and groundwater flow. So if we really want to understand what that increase in our lake sediments means, we need to understand these pathways, these linkages, in order to understand what exactly this sediment record is showing us. It's not enough just to look at the actual concentration and the trend. If we don't consider the actual mechanism by which these compounds are getting into the sediment record, then we're not getting the full picture. Sorry, so thank you very much, and I'd be happy to take any questions.
Thanks very much. I know your focus is the organic contaminants. I must apologize. I'm a trace metals guy. Bill Shoddock, University of Alberta. I've never seen an increase in tin anywhere.
Yeah.
Except for Cornwall, England, and antiquity. Any thoughts on an increase in tin accumulation rate in the sediment?
Yeah, that's a good question. I'm not a metals person. I actually am not entirely sure what that means. One of the reasons that we see the increase is because there's almost no background. So there's really no background variability to mask any trends. But I might put that question to you and anyone else in the audience who can help me figure out where exactly it's coming from. I don't know, could it be related in some way to, the Primrose site is on the air weapons range. Is there's some industrial source there that might contribute it. It matches up very nicely with the PCB's profile, which I didn't show. But yeah, no, I'm not entirely sure at this point where that is coming from.
Hi, Finn McDermott, Cold Lake First Nations. You had at one point suggested that some of the soil's pH values looked like they could be reflective of activities at Four Wings military facility there. I'm wondering if you consider the possibility that the pH values you're reading in the sediments are actually from jet exhaust, as opposed to bitumen, because when you compared those two plots of the PAHs, they only overlapped a little bit in the middle.
Yeah.
So I'm wondering if you'd established anything like a signature for the PAH contribution from military activities.
That's a fantastic point, actually. Yeah. No. Right now, again, we really haven't done much source characterization. That's really an important focus going forward. Right now, we're suggesting that it's related to the in-situ development simply because of the timing, because the increase occurs in 1985, but operations at the air weapons range occurred much earlier. But we can't rule that out at this time, and that is an important point going forward, to look at all the potential sources in Cold Lake, fingerprint them, and then start to link that to what we see in the sediments, similar to what has been done in the Athabasca region.